Good morning, Year 8. Today we're going to recap 2 and 3-step equations as we continue to recap the algebra that we first looked at last year. Let's go. So, title for today is obviously solving equations, but it'd be good to explain what that means. So the phrase solve the equation just means to find the value of whatever letter is there or whatever box is standing for it. And there is one golden rule for solving equations, which is that you should always do the same to both sides of the equation. I'm going to explain what that means with a couple of examples, but I want you to write down those 2 key points before we do. These examples, we've got 8 of them. I'd like you to copy them out, and I'd like you to make sure that you show exactly what I show. Okay, so our first equation is that 5x equals 20. Now, we want to do the same to both sides of the equation. So 5x means 5 times x. If we want x on its own, if we want to find the value of that letter, we've got to do the opposite of that. We've got to divide it by 5. So we're going to divide this side by 5. Now, because we've divided that side by 5, always do the same to both sides, we've got to divide the other side by 5. And so we'll end up with x equals 4. And we could check it works by putting it back into the original equation. The equation was 5x equals 20, and indeed if we did 5 times 4 we would get 20. So we know it works. But you don't need to show that. It's just a check you can do. Second example, we've got x plus 9 equals 5. How do we get rid of a plus 9? Well, we take it away. We need to do the same to both sides, so we take away 9 from both numbers, and we'll end up with x equals 5 take away 9 is minus 4. We could check it works. Does minus 4 plus 9 equal 5? Yes. So that's fine. So there's 8 examples in total. We're going to sort of gradually go up through the gears. What about if it said x minus 6 is 20? Well, we need to get rid of a minus 6, so we'll plus 6. Always do the opposite. Do it to both sides. X equals 26. And yeah, 26 minus 6 does equal 20. That works. And then this last one can throw people off if we see a fraction, but you've just got to bear in mind that if you see a fraction sign, that's just standing in for division. That's how algebra shows division. So think about this as x divided by 3 equals 20. We want to do the opposite of that, which is to times by 3. So that will give us x equals 60. And indeed, 60 divided by 3 is 20. So we know it works. Okay, 4 examples down, 4 to go. So here we're going to look at what we call 3-step equations. And I'd like you to write down this note that we want to remove things that aren't attached to x first. Because you've got a choice here. We've got 7x plus 2 is 37. That means there's a number, x, where if we times it by 7 and then we add 2 to it, we'll get to 37. So the thing that isn't attached to the x is the plus 2. That's what we're going to get rid of first. So we're going to take it away. And again, do it to both sides. Now if we do that, we'll end up with 7x is 35. And now we've got what we had on the previous examples. 7 times x is 35. Do the opposite. Divide by 7. Do it to both sides. We'll end up with x equals 5 as our final answer. Check it works. 7 times 5 plus 2 equals 37. Yeah, that works. So, x is 5 is our answer. What about for this next one? Again, we're going to get rid of the minus 3 first. So we're going to plus 3. That'll give us 9x equals 90. And then we're going to divide by 9. That's going to give us x equals 10. That's our final answer. 9 times 10 minus 3 is 87. Yeah, that's right. So 2 more. And again, just using the division thing. So we're going to get rid of the minus 5 first because it's not attached to x. So we're going to do that by plussing 5 to both sides. X over 6 equals 12. And then how do we get rid of a divide by 6? We times by 6. Do that to both sides. We'll end up with x equals 72. Check it works. 72 divided by 6 is 12, minus 5 is 7. Now for this last one, what we're going to need to get rid of first. The divide by 3, or the plus 9? Yep, it's the plus 9, so we're going to subtract 9 from both sides. That will give us x divided by 3 equals minus 7. Be careful with your negatives here. And then we want to get rid of this 3. We're going to times by 3. And that will give us x equals minus 21. So there's our 4 answers. And always remember, you can check by putting them back into the original equation. That means putting them in place of the x and seeing if it works. Okay, some questions to do now. So we've got a mixture of questions to attempt. I'm going to periodically show the next 3 answers, okay? And I'll tell you when I'm going to do that, but pause the video, have a go at the first 3, and I'll see you in 3, 2, 1. There we go. So I've tried to show the steps in blue and the actual writing bits in red. Now, you might be asking, do we need to write things like, minus 10 after each step? And we don't need to. That's just to illustrate what we're doing for the examples. But you definitely need to write all of the steps that I've got here in red. I do want to see the individual parts of the equation you've solved and not just your final answer. So if you think you've got it at this stage, you can just write down the steps in red. For me, 3 seemed like a bit of an awkward one, maybe, because it had the 5 at the front, but it's still not attached to the x, and we still get rid of it by subtracting it. We wouldn't add it because it's not a minus 5. Okay, I'm going to show the next 3 answers. So pause the video now, and I'll show them in 3, 2, and there we go. So these are awkward because the x's are on the right hand side, but the same rules still apply. We want to eliminate things that are near the x, so we'll get rid of the minus 3 first on question 4, and then we'll times by 4, and we'll do exactly the same. Some people like to rewrite the equations, so like for question 4, they might start by just putting the x part of it on the left-hand side of the equation, just so everything looks familiar. You might want to do that, but it still works either way. Okay, pause the video. I'm going to show the next 3 answers in 3, 2, 1. Let's go. So, what are the difficult bits here? I think the first question's okay. You subtract the 5 and take away and divide by 10. On question 8, we end up with this. If we take away the 7, we end up with 3 equals minus x. That can be a bit confusing, but you've just got to remember that if you've got just x on its own, that means you've got 1x. That's minus 1x. So all you need to do is divide by minus 1, or even more simply, if you've got minus x and you want to get to x, just flip the signs. So because we had a 3 on the other side, that becomes a minus 3. And the same is true on question 9. Okay, pause the video again. We're going to show the last 3 answers once you've had a go at them in 3, 2. So again, these are a little bit different in that we actually need to do the times first and then the add and subtract. It's been the pattern so far that we've always had to do an add and subtract and then a divide or a times. And these are one that sort of book that. So if you look at question 10, you've got x plus 5 over 3. That means the x is added to the 5 first. It's attached to the x first before it's divided by 3. So we work in reverse order. We're going to get rid of that 3. That's the furthest thing away from x first. We're going to do that by times by 3. You can obviously check your answers work. So for 10, we got x is 31. So we're saying if we did 31 plus 5 here, we'd get 36. If we divided that by 3, yes, we'd get 12. So check your answers work if you're not sure. But yeah, those are my answers. Correct any that you haven't got right. And then we've got one last set of examples to do. So I'll see you there. So we're going to look at equations that have brackets. And if they do, there's basically 2 things you can do. So this is option 1, really. And this is the one that most people go for. So they say, if there's brackets, we'll expand those brackets first, and then we'll just treat this like the equations we've seen before. So how would that work? On this first example, I'd multiply out this bracket, I'd times it all by 5. That would give me 10x minus 15 equals 40. And I'd do exactly the same as I've been doing so far. I'd add 15 to both sides, and that would give me that 10x equals 55, and then I would divide by 10, and that would give me that x equals, in this case a decimal, 5.5. You can have decimal answers, that's fine. And let's see how that would look with the second example. We'd multiply it out again, so we'd get ourselves to 12x plus 21 plus 9 is 90. And then we might want to simplify that a little bit. We've got a plus 21 and a plus 9. Let's make that 12x plus 30 equals 90. And then we can do what we've been doing. We can subtract 30 from each side. We can get ourselves to 12x equals 60. And then we can divide by 12. And that will give us x equals 5. Sorry if I'm writing that a little bit small, but that's the space we've got. However, there's also option 2. And option 2 is that we can sort of divide by the number outside the bracket. So let's do the exact same questions and see how that would apply. So here we've got 5 lots of 2x minus 3 is 40. Our first step could be divide everything by 5, because if you look at that 5, it's the furthest thing from the x. We've got the 2x and minus 3 are all inside the bracket. Let's divide by the 5. That will give us 2x minus 3 is 8. And then we've got a much easier equation to solve. So we could add the 3, 2x equals 11. And then we could divide by 2, x equals 5.5. This is a really important point, that with equations, there's not always just one way to do them. As long as you do the same to both sides and you do it correctly, you can get to the answer with lots of different ways. And that's kind of like one of the trickiest things, to just pick a method and trust yourself. What about for the second one? Well, we'd actually have to get rid of the plus 9 first, because that's even further away from the x than the 3 is. So we're going to get rid of the plus 9, then the 3, then the plus 7, and then finally the 4. This is actually kind of like a 4-step equation, but we can do it. So the first thing we're going to do is, as I said, take away the 9. This will give us 3 lots of 4x plus 7 is equal to 81. Then we'll divide by the 3. And I don't know how good your 81 times tables are, but 81, 3 goes into it 27 times. You could do yourself a little bus stop if you weren't so sure on that. Then, as I said, we're going to get rid of the 7. So that's going to give us 4x is 20. And then finally, we're going to divide by 4. And this will give us x equals 5. That's exactly the same as we got in the previous one. Now in this case, maybe you prefer the top method, but just bear in mind both options exist. You could expand the brackets first, or you can divide by the number out of the brackets. Okay, so one last lot of questions to look at. So obviously you've got the amount of time that you've got. This is what we'll be doing for the rest of the lesson. So whatever time you have left of our hour and 10, use that to do these questions. I'm going to unpause and show the answers for the first 4 in 3, 2, 1. And there we go. So I'm going to try and get away now from writing down what I'm doing on each individual step, although you can keep doing it if you find it helpful. As I said, this stuff in red is all you need to show to get your marks. Okay, check those 4, and I'm going to show the answers for the next 4. So pause again in 3, 2, 1. Phew, those are a little bit tougher. So we've got things that we've not really seen before here. So on question 5, we had a decimal answer. You had to do 26 divided by 20. So, divide by 10, divide by 2 is probably the way to do that in your head. We had brackets where we had minuses involved. So we had to divide by negative numbers, say here in question 6. And we had to divide by a negative number here in question 7. But yeah, those are the answers you should get. 1.3, minus 4, minus 2, and 11. And I'm going to show the last 4 answers. So pause again, have a go in 3, 2, 1. Phew, and there we go. So some of these again are quite tough. The thing I think I want to point out on question 9 is that you end up having to do 20 divided by 6, and that's not a pleasant sum. And we could bus stop it and get to like 3.333 or whatever, but you can always write it as a fraction. If I want to do 20 divided by 6, then I just write 20 over 6 and simplify that fraction down. Really useful tip. And if you just left it as 10 over 3, that would be fine. Question 5, question 10, 11, 12, I think they're all okay. On 12, you've got to make sure when you expand that you get this plus 6 here. Remember, you're doing a minus times a minus from yesterday. So yeah, that's it for this, and that's it for this week. No homework today. Have a good week.